All right, we are in Chapter 4. We are again working on some practice problems with these to make sure we are good to go. And understanding all this in Unit 1 for AP Stat. Again, pause these, write down the problems so you guys can get working on this stuff as well. But it says that a clerk entering salary data into a company spreadsheet accidentally put an extra zero in the boss's salary, listing it at $2 million instead of $200,000, and explain how this error will affect these summary statistics. The measure of center, median, so on. Well, again, if you plug this in, it's going to drastically change. It's going to pull that median way, or the mean way up of their averages. It won't affect the median too much. Everything should probably still be, for the most part, pretty much the same, but will affect that center data. So as long as the boss's true salary is that, it's still above the median, right? So that should be fine, but the median will be correct. That's not going to change for the most part. The mean will be too large. Notice that the total of all salaries will decrease by that amount. Like, it's going to change once the mistake is corrected. So the median will definitely change, is what that's saying. But the spreads, the range will likely be too large, right? Because you're going to go low to high. That's probably going to be the high, so that will change. The interquartile range will likely be unaffected because you're putting that way out in an outlier, so it's not going to change what that range was. It might alter it like a little bit, but it's not going to alter it much at all. The standard deviation will be too large because of that as well, because the mean changed, and because the mean changed, the standard deviation is also going to change as well. Taking a look at this data, the histogram shows the budgets of major released movies in 2005, and they appear to be skewed to the right. Okay, an industry publication reports that the average movie costs $35 million to make, but Watchdog Group is concerned with rising ticket prices, says that the average cost is $46.8 million. What statistics do you think each group is using? So, because it appears to be skewed to the right, pulling the mean up more, I would say that they're probably using the mean because that's higher, and they're probably using a median when they're doing it. So the industry publication is using the median, while the Watchdog Group is using the mean, and it's likely being pulled. That is being pulled by the mean the whole way up because of those expensive movies is basically what we're getting at. Taking a look at this one, a small warehouse employs a supervisor at $1,200 a week, and inventory manager at $700 a week, 6 stock boys at $400 a week, and 4 drivers at $500 a week. So it says find the mean and median of the wages. Basically, you could just sit there and say 6 times that, and you could say 4 times that. You have one of those and one of those. Add them all up, but then it's how many total people were there. 1, 2, that is 6. Is 12, so you would just take them and divide by 12. The median salary would basically be you taking all of those and aligning them, and after you take them all and align them, finding the middle of the data, which is around 450. So you could basically get them each by doing that. Pretty simple. How many employees earn more than the mean, right? So if the mean is scheduled, the mean wage we said was scheduled at $5.25. There's really only 2 people that would make more than that. All right, and then which measure of center best describes this wage? It looks like it's having some outliers there. I'd probably go with the median myself. Only 2 employees, we said. The median probably does a better description of the typical things because the mean is affected by those higher wages that there are there, those 2. The interquartile range is best measure of spread for the payroll simply because you can get rid of those outliers. The standard deviation and range are both affected by those outliers. So again, oftentimes if you're going to use the median, think about it in terms of doing box plots. Think about it in terms of doing quartiles and interquartile range. If you're going to use the standard deviation and the mean, they're going to go together because we have those normal curves that we will be talking about down the line, and they all kind of connect and go together. The stem and leaf plot display shows populations of the 50 states and Washington, D.C. in millions of people according to the 2000 census. And it's looking like it's skewed, but it's skewed, that's the low, so it's skewed to the right because that's the higher end. So the measure of center most appropriate because the data is skewed. It's probably going to be for this one as well because it's skewed. You're going to want to go median on that. It's skewed heavily to the right, the higher end, and therefore the median and the interquartile range would probably be more appropriate. But then it says, without doing any calculations, which must be larger, because it's pulled down, the mean is going to be larger since it's pulled to the right. So the population mean must be larger than the median. It's going to be pulled by those extreme values down that way. From the STEM Elite display, find the median and the interquartile range. Well, you count them all. Basically, to summarize, you count them all, and then you try to find the exact middle. And when you do, right, there are 51 entries. So that 26th entry would be the median, and counting to the 26th spot, you end up getting 4 million is basically roughly where you're at if you count. The middle of the lower 50, then there's 25 that are lower, so it'll be in between the 12 and the 13 one, so right in the middle. Sorry, the 13th and the 14th in the list, which is about 1.5 million, and then the upper 50%, those 26, between those, the 13th and 14th one there, so that's around 6. Basically what I'm saying is you count, you found the middle to be around there, and then you find the middle of those and the middle of those to get your quartile range to be roughly in between 4.5 million. You could also just plug these all in, all these values, and it would tell you what the value means, the median, the interquartile range as well, if you want to do it like that with your calculator. And then, part D, write a few sentences describing the distribution. So you got to get used to doing that. The distribution of the 50 U.S. states, Washington, D.C. is skewed to the right. The median population is 4 million, with 50% of the states having populations between 1 and 6, because that's your quartile range. And because you know it's skewed, then you're going to decide which value to use. That's why I'm referring to everything in terms of the median and the quartile range, referring to those outliers as well. If we were talking about it, saying that we would use the mean to describe it, then I would talk about the standard deviations away, is basically what we would do. 2 researchers measured the pH of water collected from rain and snow over 6 months during an Allegheny County, PA period of time, right? And they described the data with a graph of a few sentences. So you could organize the data, describe the data with a graph and a few sentences. So I could plot all that data, maybe make a histogram out of it if I wanted to see what it kind of looks like. And let's see if they do. There you go. So a nice histogram of all the data. And it kind of looks like there might be a little fluke out here, but it does kind of look like there's a possibility of something being bimodal. A little lump there. Doesn't necessarily make it another mode, but it says the distribution of pH readings of water samples in the Allegheny County is bimodal. Right here, a lump and another little lump right there. It's roughly uniform. Cluster is, the first one is centered around 4.4. That's where it looks to be centered around roughly, which seems pretty accurate, right? I mean, if you look at it, that's where it's roughly around. The other cluster, 4.19, where is it at? This cluster ranges from the range of that cluster, 4.1 to around 4.9 is what they're saying is that cluster. Another small cluster is centered around 5.6 as well. They just want you to describe it. It's centered around there. So it's just kind of you getting used to looking at this data and maybe making tables out of it, stem and leaf plots out of it, box and whisker plots out of it eventually as well. Kind of going through all this data to make sure we know how to use it is basically all we're looking at. All right. So I hope that was helpful with getting some of these answers, seeing some examples, going over some of the data here in Unit 1.